So in this video, I'll be taking you through how to answer from the IGCSE Cambridge Geography Paper 2 exam, the paper that was set back in March 2023. So why this video? Really, if you have used the comments to download the paper and have it open in front of you, this video offers you a range of hints and tips on how to approach answering the map skills question. Every paper 2 has a 20 marks that starts with map skills, and this way is a useful video to show you how the March paper was answered and then how you can apply the skills from that, the knowledge, the content required to answer that paper to other past questions. So my advice, have the paper open, watch as you go, or use it with another past paper that asks similar questions and skills. So just to recap, the map skills question is 20 marks out of a possible 60. It's compulsory. I would advise you to spend about 30 minutes on this. Primarily the questions are based on settlements and rivers, but it can ask topics from coasts and tourism as well. It's really important you have a protractor with you, a ruler, a pencil, a sharpener and a rubber when answering these questions. Now, before starting the exam, there's several things that you need to do. First of all, you need to draw this onto the large map extract, a compass with all of the bearings. This will help you answer the questions that come up on direction and bearings. Secondly, you need to look at the scale and contour lines and circle what the contour line interval is and what the scale is. And remember that when it's a 1 to 25,000 map, that means that 1 centimetre on the map is 25,000 centimetres in real life. And that means that 1 centimetre is 250 metres. Remember, another common scale is 1 to 50,000 or 1 centimetre is 500 metres in real life. So pretty much all of the map skills questions start off with this. You have a figure that extracts an area of the map and has some features identified, and you need to be able to tell me what those features are based on the map. Now, the first thing to remember with this is that the map extract and figure numbers have the same dimensions. What I mean by that is when you draw the outline of this figure onto the map, the grid squares are the same. So one grid square should be 4 centimetres. And so that is a really useful reminder to help you answer these questions, because knowing that it makes life a lot easier for other questions. So we look at these two map extracts. We need to identify the river A, what FB means, land use of this area C here, this point at D, and the railway station at E. So we need to work out the name of a river. So that A, that gives you a clue. So we see a black line and it says the name of the river at A. So we simply work out the name is Sutherland Barn. We then need to work out feature B, so that's FB. And so we find out which part of the map that comes from. Okay, so FB is footbridge, so I'm going to write footbridge. We then need to work out the land use at C. Now, at first look, you might think it's non-coniferous trees, but this is when you have to be really, really careful. If you zoom in and you look very carefully at that area that's been identified, it's actually both non-coniferous trees and coniferous trees. So again, you have to be very careful with some of these, because they're now looking like they're throwing in quite nasty little questions that are trying to trick you. And then D, and this is quite naughty because really there's a triangulation pillar there, not a spot height, which they've put in figure 1.1, but it's easier to read off, so you've got 387. Usually they'll actually draw a triangle onto the figure. And as you can see here, we've got them all right. Now, these questions ask you to look at the 6-figure grid reference. Now, when I did this, I actually went against the mark scheme because, and I'll explain to you why. So we need to identify the feature E on figure 1.1. So there is E clearly there. Now, to do the 6-figure reference, we need to find the feature and circle it. Makes life a bit easier when it comes to identify. We check the scale, so we know that each grid square is 4 by 4 centimetres square. We first of all work out the 4-figure grid reference. So in this case, we've got the bottom left-hand corner, and we know that if we go along the corridors, the number that's in line with the bottom left-hand corner is 21, and then we go up the stairs to the number that's aligned, so that is 54. We then leave a little gap for 21, space 54 space, because the 6-figure grid reference tells us the exact location within that grid square, and it tells us, and so we need to find out the third and sixth number. To do that, we remember that when it's 6-figure grid references, the third and sixth number goes anywhere from 0 to 9, so there's 10 numbers. So we do 40 millimeters divided by 10, so that's 4 millimeters equals 1 point on the map, so 1 point of this third and sixth number. Now if we look here and I get my ruler across, we can see that the first one is about 3 millimeters from the left edge, so it's close to 1 point, I would argue. Now please remember this, because in the mark scheme it says it's 0. I personally would argue that if it was 0, the railway feature would have to be exactly on the line. Because this is quite far from the line in this particular case, I would say it's closer to 1 than 0. And then again, we take the center of the circle, and so we go close to 7 points if I put my ruler up against it. Now, when I do this, I write the answer 211547. The mark scheme gives me 210546. And this is one of the rare occasions where teachers are able to appeal the mark scheme. I do not think that it's 0, because it should be on the line. And if you look at it and you break it down, a 6 or a 7 in the center of the circle. So I think the exam board have made a mistake here. What do you think? Put it in the comments below. What have your teachers thought about this? Again, put it in the comments below. It'd be useful to share in the wider community. Now moving on, we've got the distance along the railway line from the railway station at E to the southern edge of the map extract. And we need to work this out in kilometers. First thing we're going to do is work out the railway line. Okay, so that's the key. So I'm following those 2 points there. And I've highlighted it for you so you can see what it looks like. Now I've put this on its side, the map on its side, just to make what I'm going to show I would answer this question a bit easier. First thing I would do is divide up the railway line into as many straight parts as possible. So you can see all of the straight parts are kind of loosely identified here. I would then take my ruler and I would measure each straight path in centimeters. So we've got 2.6, 2.3, 1.9, 3, 1.5, 4 centimeters. I'll then add up the lengths, so it gives me a 15.5, and then I would times it by 0.25 because I need to put it into kilometers. If I was doing this into meters, I would do it slightly differently, but because I have to do it in kilometers straight away, I just times it by 0.25. So that works out how many 250 meters go into this figure, or I would just divide by 4, one of the two. And that comes up to 3.825. Mark scheme, 3.88, but they accept anywhere between 3.75 to 3.95, so nicely in the middle. Now, alternatively, you could bring in a piece of string into your exam, and then somehow, and this might be longer than my method, put it along the railway line and then measure it against your ruler and then do the calculation. It's entirely up to you how you go about doing this. Another one you have to do is work out the bearing. So this is where your protractor comes in. So to do this, you circle the start and the end. Now remember, and this question is worded slightly differently, you're going from the railway station at E to the end of the railway line. So you're going from, or the start point is the railway line, the railway station, sorry, and the end point is where the railway line goes off the map extract. I would then draw a north arrow at the start, and then I would connect the points with a straight line. I'll then take my protractor. Now, again, top little tip, you might want to buy a 360-degree protractor because that makes life a bit easier. If not, go back to your bearings here. Now, you know that because naught is at 0, you are going beyond 180 degrees. So you're going to the left of 180 degrees. So you are more than your protractor. So what you need to do is work out what the difference is. So in this case, if you look at it, I'm at 10. So you look at the bottom numbers on my protractor, it's got 170 or 10. So I'm going 10 degrees beyond 180. So therefore I have 190 degrees. And there's my answer there. Again, nicely in the middle. Remember, if you had a 360-degree protractor, it'd make your life a lot easier. If not, remember, if you only got 180, 180 is south, 90 degrees is there. Because I've flipped it on the other side, I am adding the degrees that you can see to 180. So in this case, I've gone 10 degrees beyond 180, so 180 plus 10 to give me 190. Now if I wanted to work out the bearing, the bearing there, again 190, somewhere between south and south-southwest, so I write that as my answer, and that's a common question that comes side by side with this exam. Now the next one requires me to identify 3 tourist attractions shown on the map extract. Here is the map extract. Now sometimes the key actually identifies tourist attractions and leisure information for you. Now it's worth remembering, and I've got a video here, another video on my channel that goes through tourism, so please check that out, what a tourist attraction is. It's a place, event or object that is popular among tourists and is visited for its unique or significant features. So it's something about that area that has attracted people to it. You can see here, most of those things are reasons why an area a person might go to, but there can be other things as well that may be not on that tourist and leisure information. So what features can I identify from this map? Well, again, I use the tourist and leisure information, and I can see there aren't that many symbols in this part of the map, apart from the little fish, which is for fishing, and on the reservoir there. So I might need to look at other features that I can see. Well, there's a nice coastal path going along the map, so that implies walking. As well, we've got some waterfalls which might attract people to go and see. So here I'm going to put some other tourist attractions on the map. I've got the coastal path, I've got Langford waterfall and fishing as well. So you can see these areas that I've identified for you. Now if you look at the mark scheme as well, there's loads of other things that they identify. They've got the beaches themselves, they've got the pier. So again, you're thinking about what would attract people to visit. Now we're still looking at the whole map, and for this question we need to look at the types and distribution of vegetation shown on the map extract. So let's break this question down. First of all, let's look at vegetation. So I look at the key and you can see all of the various symbols for vegetation there. And perhaps the easiest ones to find out are the ones highlighted, or the ones that are in green, bold colour, the coniferous trees, non-coniferous trees and the coppice. So I've looked at what vegetation types can you see? Well, I can see both coniferous trees and non-coniferous trees. I want to know where they are found, and I want to identify if there's any particular relief landform, roads or railways that might have influenced where they are particularly located. So if I look at my map, another useful thing that you could do to help you is with pencil is actually write on north, south, east and west, because then that helps you to identify which parts of the map certain features are found in. So if I look at these vegetation types, again, like I said, coniferous trees and non-coniferous trees are very popular. I can tend to see them towards the west of the map there. So I'm going to put this in as my opening 2 points. I'm then going to break this down a little bit more to find out, are there any features that have sort of determined where these various vegetation types are found. So again, I've got my north, south, east, west. Well, this area, a lot of the coniferous trees are kind of located next to the railway or along streams and the steep-sided slopes. If I go to this area, you can see that the non-coniferous trees are around land that has virtually got no contour lines, devoid of contour lines, so it's relatively flat. So with those points in there, I could say coniferous trees are found along the main railway line and along steep-sided river valleys. There is also an area of non-coniferous trees in the southwest part of the map where the land is flat. More than 4 points, but you can see from the mark scheme how I've gone about doing this. There is actually, I looked at the map evidence, I found out first of all, what's the main types, wrote those down and where they are found. So again, north, south, east, west on the map might help you to do that. Now, this question for 6 marks is a lot, and so I'm going to break this down to you step by step, so please follow. Describe the drainage pattern east of Easting 21 shown on the map extract. The first thing that might confuse you is, what do you mean by Easting 21? Okay, so let's just break that down for you. On a map, here you go. When you're going, think of it like an X and Y axis. When you're going up the map, okay, from 51 to 55, that's kind of like a Y axis on a graph. You're going further north. So we call those northings. Okay, so these lines are associated with northings because they're going up the page. Now, eastings are when they're going along the corridor, along the x-axis. And so you can see all of these lines are eastings. And so when it comes to this question here, it's asked us to east of easting line 21. So there is the easting line 21, and I've shaded the part of the map that we can ignore. So we're only focusing on that area that you can see. Now, this again, I think is quite tricky, and it does require you to know what we mean by drainage patterns. So what I'm going to do is just explain what a drainage pattern is, and then take you through 6 very common, but 6 main types of drainage patterns. There are more, but these are the 6 sort of common ones, I could say. There is like a major one, but a lot of the ones that so you can sort of easily see on a map. And so if you know all this, please wind forward to the actual part where I answer the question. If not, please do quickly follow and take some notes. So a drainage pattern is an arrangement and layout of the river network within a particular drainage basin. So it's pretty much, if I extracted all of the land use and I only left the rivers, the blue lines there on my map, it's basically a way to describe that pattern. And so it's an overall pattern of all the streams and rivers that drain water from the land and flow towards a common outlet such as a lake or the ocean. So it's what does that look like? So there are lots of different types, and I've taken this from the website here that I've been linked to. So we've got dendritic, which is perhaps, it resembles the branching pattern of a tree with smaller tributaries joining larger rivers. It's uniform and consistent underlying geology and slope with no prominent structural control or preferential flow paths. Basically what that means is that because it's relatively even ground, it's just sort of normal. There's nothing particularly unique about the land that the drainage basin is on. It leads to this very, very common pattern where there's just lots of small rivers that join much larger rivers, eventually join the main river. The next one is what we call a trellis, and it's where main rivers flow parallel to each other while shorter tributaries join them at right angles. So you can see that here. Basically, if you've got alternating layers of resistant and easily erodible rocks, it creates this pattern along the joints or the faults. The water's flowing in between the lines of least resistance. So we have a parallel drainage pattern, pretty much where rivers flow parallel to each other, maintaining the same sort of distance apart. And think about if the river's flowing in areas that's got very steep slopes, and so it causes the rivers to maintain a consistent path. There could be other reasons for it as well. We've got a rectangular drainage pattern. Pretty much that's where rivers flow in straight perpendicular lines, resembling a grid-like pattern. There could be a whole variety of reasons for that, but it's something that's very kind of like straight lines, right angles as well. A radial drainage pattern, pretty much imagine this is like a mountain or a volcano, or on top of the mountain there's loads of snow, or the hill, or there's loads of ice. Anything that basically that when that water melts, it flows in all directions from the top of the mountain. Okay, so a river radiates outward from a central high point such as a volcano or dome, top of a mountain or a hill. We've got deranged, pretty much there's almost no pattern with rivers flowing in random directions, flows into lakes, larger lakes, back into smaller streams, whole different reasons for that. And that could be tectonic activities, glaciation, or geological processes that disrupted the flow. It could even be due to human influences such as building dams at various points. So you've got all of those. There's other bits of data that we can look at too. So we can look at it from the point of view direction of flow. Does the river drain in a certain direction? Are there particular relief features such as a mountain, steep slopes that might affect the direction of the drainage pattern? What about the width of the river? Does it vary in width as we go along? Because that influences its ability to hold water, the amount of water it holds, and other landforms that could disrupt the drainage flow. So for example, is there a waterfall, are there lakes that again could influence how the water drains and the amount and type and rate of drainage. Okay, so first of all, I'm going to look to see if there's tributaries, meanders, waterfalls, lakes and reservoirs. All of those are present, which implies there's lots of tributaries. There's a high drainage because there's lots of water within the drainage basin. So I'm going to make a note of the fact that there are many tributaries, the river does meander, there are some waterfalls along its routes, and the water flows into at least 2 reservoirs that we can see, and I might make a note of those reservoirs, the name of those reservoirs as well in my answer. Now, all of the rivers tend to flow in this direction here because they all start off. You can see the sources of where those streams are because they don't continue. So that's where the river starts, and they all flow downhill, joining various main rivers into the reservoir itself. And so with these, I can say that the river flows in the south. The rivers tend to drain in the southeast direction. And if I look at this hill here, you can see that lots of streams and rivers are flowing off this hill. So that's a radial pattern. I also want to remind you that actually the most common type of drainage pattern is dendritic. So if in doubt, put both. If you can see a hill with streams flowing off, that's radial, or volcano, whatever the map extracts on. And also it's probably dendritic as well. So if I bring all of that together, so bringing those points together, I can say there seems to be two main types of drainage patterns, dendritic and radial, especially around Came Hill. The various narrow streams and rivers tend to flow in a southeast direction into various reservoirs, such as Knockenden. And there are lots of tributaries, meanders and waterfalls with streams surrounded by steep-sided valleys. So when I look at the mark scheme, yep, small narrow rivers and streams, got that. Many tributaries, confluences, affluents, join small rivers, got that. Meanders, got that. Radial pattern mentions, dendritic pattern mentions, waterfalls mentions, flowing into reservoirs mentions, generally drains in a southwest direction, southeast direction, depending where you're looking, mentions. So yeah, lots of points simply by looking at the map, looking at the direction of flow, looking at if the river's narrow, what features I can see that all apply to drainage patterns. So looking at the amount of water flowing through that area and in what sort of pattern are they in. So thank you for watching. Just to recap, drawing any boxes or lines from the figures of the exam paper onto the A3 map, drawing a compass with bearings, identify the scale and contour line interval, and take it slowly. If you've enjoyed this video, if you think it's been useful, share it with your mates, like it as well. If there are any questions, please do comment. I endeavour to get back to you as quickly as possible. Good luck. And remember, practice does make perfect for this exam question.